the role these ancient microorganisms played in shaping our planet. These microscopic pioneers had a remarkable talent. They could harness the power of sunlight to convert carbon dioxide and water into energy-rich organic compounds, all the while releasing oxygen as a byproduct. At first, this oxygen had little effect on Earth's atmosphere. It reacted with elements like iron, forming minerals that were then deposited as rust on the ocean floor. But as the ages passed, the oceans became saturated with iron, and a surplus of oxygen began to accumulate. This marked the beginning of the Great Oxygenation Event. Oxygen levels in the atmosphere began to rise, setting the stage for a profound transformation. As oxygen spread through the oceans and atmosphere, it brought about a revolution in the diversity and complexity of life. But this transformation wasn't without its consequences. The oxygen was toxic to many existing organisms that had evolved in an anaerobic oxygen-free environment. Those that survived had to adapt or perish, giving rise to new forms of life that could harness the energy of oxygen-driven metabolism. The Great Oxygenation Event laid the groundwork for the evolution of multicellular organisms and the rise of more complex life forms. Oxygen became a precious resource that fueled the energetic demands of larger organisms, paving the way for the diversity of species we see today. Let's also explore the captivating theory of panspermia. Panspermia provides a fresh perspective on the age-old question: how did life emerge on Earth? Instead of relying solely on local conditions, this theory expands our horizons, suggesting that life's origins might have been influenced by cosmic events. Panspermia proposes that life's building blocks, molecules, amino acids, and even tiny organisms, could have hitched a ride on comets, meteorites, or interstellar dust, traversing the vast expanse of space. These cosmic travelers, encased in protective shells, might have survived the harsh conditions of space, such as extreme temperatures and radiation, before plummeting onto Earth's surface. Upon impact, they could have carried the potential for life, depositing the necessary ingredients in the nurturing embrace of our planet. Panspermia also forces us to ponder the interconnectedness of all things. It prompts us to imagine a universe where life might not be an isolated occurrence, but a cosmic phenomenon that transcends boundaries. Before we address the burning question, when do experts believe life first emerged on Earth? Let's have a quick recap. We've journeyed